When solving systems of linear equations, we've seen how to solve them by substitution, elimination, and graphing. Now that we're going to be adding in quadratic and exponential functions as well, we're going to focus on solving them by graphing. That's by far the easiest way to solve systems of nonlinear equations. So right now this is just a recap of two linear equations. These are both lines. We don't have squared. The x is down with the number instead of up as an exponent. And when we solve these, we wanted to know their intersection point. You can think of these as two separate functions because all lines are functions. They are functions. I'm going to call the first one f of x to give it a specific name, and the second one g of x. Where these two are equal to each other is the solution. We actually want to know, where does f of x equal g of x? So as an equation, that would be actually setting these two things equal to each other. As a graph, that's where the two lines intersect. The point of intersection is the solution for this system of equations. So we go and we type in the two functions, y equals 3x minus 5 and y equals 2x minus 4. And we see the intersection just pops up. You see a couple of gray dots. They're all important points, but the point we want is where the two lines are actually crossing each other. Where they cross the x-axis, the x-intercept can be important for some questions. Where they cross the y-axis can be important for some questions. We want this point, 1, negative 2. So our answer, our solution, the point of intersection, that's all different ways to say this ordered pair right here, this coordinate, that is our answer. The x value is 1, the y value is negative 2. If we wanted to check, we could go plug them back in, and when we plugged it in, we'd find a true statement. But usually we skip that step because we just want that solution. Now there's different ways the same question could be asked. All of these that I have in boxes, they're actually the same question, just phrased a little bit differently. Instead of just saying solve the system, they could say solve the system of equations for x and y. They could say a system of equations is shown. What is the solution to the system of equations? Find the point of intersection for the following system of equations. Or a system of equations is shown. Find the ordered pair where the functions intersect. All of them look a little bit different, but all of them have that keyword of system of equations. If it says that keyword, that means you're going to graph them and find where they cross. Now it is possible for them to never cross. We did learn that when we were working with linear functions. Maybe you have parallel lines. These aren't quite parallel, but pretend. Let me try one more time. Those are a little closer. They'll never cross each other. So that would be no solution, or you can have one solution where they do cross each other. Or the weirdest one is when they overlapped and you had infinite solutions. If you had a second line that just went exactly on top of the first, that was called infinite solutions. When we have newer functions like our quadratics, when we find our points of intersection, now we have other options of not just no solution or one solution. We might cross 2 times and have 2 solutions. So it's still possible to have no. Maybe they never cross at all. It's still possible to just have one point of intersection where it would just barely touch. And it's possible to now have 2 points of intersection, 2 solutions for this system of equations. So again, it's just phrased a little bit differently, but it says for the following system of equations, that's our key word, find the points of intersection. They want us to solve this and round to the nearest 10th. So once again, we go to the graphing calculator and type them in. I'm going to get rid of my other ones by hitting the x, and I'm going to type in the y equals x squared. So you could use your keyboard to get squared, but it's easier to just click on this a squared button. So x squared, oh, I made a mistake. I should have put negative 2x squared. I have this written on a separate sheet of paper because it's hard to flip back and forth. So negative 2x squared plus 3x plus 1. That's our first equation, our first function. And y equals 2 over 3. When you want a fraction, you hit the divide button. That actually makes the fraction for you. But before you type x, you must click to the right. I had to click right there to type in x. Otherwise, it puts it in the bottom. Let me show you really quick. If you put the x on the bottom, it makes a really weird function. You'll know, hey, that's not what I want. So click to the right, 2/3 x plus 1. And now you can see they cross 2 times. This one is 0, 1. That's our first solution. And then 1.167, 1.778. So 0, 1. And then Desmos showed 1.667, 1.778. Oh, 1.167. Wanted to double check that. 1.167. But the question did state to round to the nearest tenth. So we want the first digit after the decimal. And we decide, is that going to stay a 1 or is it going to go up to a 2? Since the number next to it is a 6, this is going to round up to a 2. We look at 1.778 and we do the same process. The number right after the decimal is a 7, so we're either going to keep it a 7 or round up to an 8. The number next to it is a 7, which is 5 or bigger, so that rounds it up to an 8. So there's our 2 solutions.